use calculus to determine the coordinates of maximum and minimum of the function f of x is x to the power 4 minus 2x squared plus 12. So here you got a function f of x which is equal to x to the power 4 minus 2x squared plus 12. Now to find the maximum or minimum, you have to first find the derivative and set that equal to 0. And then we have to use the test of derivative to decide the maximum or minimum. So first let's find f dash x. Okay, f dash x is a different, so this is nothing but y is equal to f of x. So f dash x, or that is same as writing dy by dx. You drop the power down, that is 4 drops down and that becomes 4x, and decrease the power by 1, so this is 4x cubed, minus, drop the power down, so 2 times 2 is 4, x to the power 1, I'm not writing, and the derivative of 12 is 0. So now for maximum or minimum, for max, this is local maximum and local minimum. Okay, so I'm not going into local maximum. I'll come to what do I mean by local maximum later on. It can be a global, there are two maximums. There can be, it's not always necessary to have maximum. So when you're talking about maximum minimum, we're talking about local maximum or minimum. I'll come to that later on. Okay, so there are two types of maximum. One is a local maximum and a global maximum. In the same way, you can have a local minimum and a global minimum. So I'll come to that later. So for maximum and minimum, your dy by dx, your gradient has to be 0 at maximum or minimum. Your gradient is 0. Again, let me explain this. I have done this a number of times. So if a graph like this, okay, this is called maximum. At this point, or this is local maximum, so here the gradient is 0. And if a curve goes like this is called concave down, and this is called concave up. At this point, the gradient is 0. Gradient of the tangent at this point is 0. So I'm going to set this equal to 0. We already found dy by dx, which is 4x cubed minus 4x. So let me change color. So this is 4x cubed minus 4x is equal to 0. So now we have to do a little bit of factorization. So what can you factor out? I can factor out 4x. So we got x squared minus 1 is equal to 0. So this implies this is 4x. How can we factorize this? This is difference of two squares. So this is x plus 1 times x minus 1 is equal to 0. So setting each of them equal to 0, I hope you can see that x is either 0, x is say negative 1, or x is equal to plus 1. So let's write them in a particular order from the descending order. So x is equal to negative 1, x is equal to 0, x is equal to 1. Okay, x is equal to 0, or x is equal to 1. Okay, so let's find the coordinates. Okay, so so the function is, if you put 0 here, so let's use calculator. So let's go to calculator and table. It's easy, you can do it without the calculator, but I'm a bit lazy now. So x raised to 4 minus 2 x squared plus 12. I'll go from set from minus 1 to plus 1. Step of 1, that's fine. So at minus 1, you've got 11, 0, 12, 1, 11. So we have the coordinates. But now we need to decide whether what's maximum or minimum. So at negative 1, you have the y coordinate is 11. Here the y coordinate is 12. And here your y coordinate is again 11. So from just looking at the coordinates, you can say this seems to be maximum. Okay, so I'll put a question mark. This seems to be a minimum. I don't know. I'll have to use maths to prove that these are what they are. It seems to be. Okay, now this is called the test of derivative. I'll call this the test of dy by dx. Test of dy by dx, or derivative. Now for test of derivative, we are only looking at what's the derivative, or what is dy by dx before and after the point. Okay, now if this is the maximum, if this is maximum before the maximum, you'll if you take an arbitrary point, you'll have a positive gradient, and after that you'll have a negative gradient. And for minimum, before the minimum, you will have a negative gradient, 0, a positive gradient. You have to show that. Okay, so let's make a table. So x, we are taking only x and dy by dx. We are only taking x and dy by dx. So let us make up a table, a neat table. Okay, so this is, we need 6 points. I'll explain. 9 points. Okay, what do I mean? So let's start with -1. At -1, we know the gradient is 0. Okay, take a point to the left of negative, very close to -1. Okay, if you go to the left of -1, you have -1.1. Okay, and to the right of -1, you have -0.9. Okay, so this is one test. So I'll go use my table. The only thing that I have to do is I have to change my setting. I have to turn the derivative on. I'll turn the derivative on, and I want my range from say, let me go from minus at a step of 0.1. Okay, so 0.1. I'll go from -2 to +2 at a step of 0.1. So I'll explain. So at -1, so let's go to first -1. At -1, your gradient is, don't look at the y, this is your y coordinate and this is your derivative. So this is your dy by dx. At -1, your gradient is 0. So let's write that first. We wrote it. At -1, your gradient is 0. Okay. To the left of -1 is -1.1. What's the gradient? Is -0.929. So your gradient is minus here. And to the right, okay, to the right of -1 is -0.9, which is positive. Okay, so I always draw from a negative gradient. From a negative gradient, you're going to 0, and so this is from a negative. So this, sorry, this is not a negative gradient. From a negative gradient, the curve would look like this, isn't it? This is a negative. At this point, at 0, at -1, you have a gradient of 0. To the left, you have a negative gradient, and to the right, you have a positive gradient. So this is confirmed to be minimum. Okay, so let's now go use a different color. We want 0, to the left is -0.1, and to the right is 0.1. Okay, so we need one more line here. Okay, and let me select this, complete the table. So now we'll go to 0. At 0, let's go to 0. At 0, your gradient is 0. So let's, at 0, your gradient is 0. Okay, and to the left of 0, which is -0.1, your gradient is positive. So this is positive. And to the right, which is 0.1, it is negative. So from a positive gradient, this is positive gradient, 0 in negative gradient. Okay, so this is your 0 gradient. At this point, your 0 gradient, you've got a positive gradient to the left, and to the right, you have got a negative gradient. So this point is maximum. And finally, we want to go to 1. Okay, so let me use this color. So 1, to the right of 1 is 1.1, and to the left of 1, you got 0.9. Okay, again, let us go to 1. It's a very slow process, but it's very exciting. At 1 you have a gradient of 0. To the left you have negative gradient, and to the right, so let's see, this is at 1 you got a 0 gradient. To the left of 1, which is 0.9, you got a negative. So from negative, 0, positive. Okay, so here you can say from a negative gradient you 0, and then you got a positive gradient. So negative gradient, 0, positive gradient. So again I'll repeat it. Always good to repeat. So this is a negative gradient, then at this point you got a 0 gradient, and to the right you got a positive gradient. So this is minimum. Okay, I've drawn the graph just for interest. So if you want to check this, okay, now from these points you can decide logically, if you look at it, this is never going to be negative, okay, because this is always going to be positive. So this 12, and you put any number here, this is always going to be positive, this is also always going to be positive. Okay, so to show you the graph graphically, so let me go to graph, and this is my equation. Okay, and I've set the scale like this. I'll set the scale from say -2 to +2. I'll go at a scale of 1/3. I'll explain why 1/3 later on. And from on y minimum I'm going to put 0, and y maximum I'm going to put 15. The scale of 3, and this is your graph. Okay, can you see this is your graph? And JSOL, you can also check it. This is called local max. Now let me talk about local maximum. This is not the absolute maximum. This graph will have other maximums, which is infinite. Okay, but in this range between say -2 to +2, this is the local maximum. Okay, you will have, this is the local maximum. These two are local and global maximum, because minimum. This is a minimum, so GSOL. This graph will never go below 11. Okay, this two, the graph is never going to go below 11. So you can say call this the global minimum or the local minimum. Okay, so you can call this specifically the global minimum because your graph is never going to go below 11. But your graph can go beyond 12, because if you go to GSOL maximum, this is not the global maximum. It is the local maximum, because as you can understand graphically, if you go to the left of -1, so let me show you. So ycalc when x is say -3, the range is not, so let me change the scale argument. So let me change the scale. Let me go to 50. Okay, scale of 3. Okay, GSOL ycalc when x is -2. Let's take -2. Can you see at -2 you have a value of 20, which is greater than 12. Okay, now I've drawn this graph. What I've done is I have taken the screenshot of my calculator, and this is the graph it looks like. I have taken at a scale of 1/3. So this point is a very crucial point. You will learn this later on when you're learning second derivative. At 1/3, at negative, this is -1/3, sorry. This is -1/3, this is -2/3, and this is -1. At -1/3, this graph, this much of the graph is called concave up. It's very interesting in calculus to learn these things. So for this you have to learn the second derivative. This part of the graph is called concave up, okay, and this is also called concave up. And this part is called concave down. And this is where the curve or the concavity of the graph changes. So from this point at -1/3, your graph changes from concave up to concave down. So from -1/3 to +1/3, it's concave down. And from from +1/3, from concave down, it starts becoming concave up. So these are called the points of inflection. You'll learn this later on if you're learning higher calculus. There are 2 points of inflection. This is where your graph changes the shape from concave up to concave down and from concave down to concave up.